All right, for this next problem that we have here, we're going to relate stoichiometry like chapter 3 with gas law in chapter 5. And here it says complete combustion of methane leads to formation of carbon dioxide gas as one of the products. In one experiment, 2.5 liters of CO2 is collected over water at 25 degrees C and 765 torr. How many grams of carbon were in the original methane sample? So again, to do anything with stoichiometry, we need a balanced chemical equation. So combustion, CH4, plus O2 gives us CO2 plus water. Okay, and to properly balance this, 1 to 2 to 1 to 2. All right, well now we are going to we have information to figure out the number of moles of CO2 that were in the sample. And we can do that using the ideal gas law, PV equals nRT. Okay, the pressure here, I have to do a little bit of work. So the total pressure is 765. It's collected over water, and so I have to subtract out the 28 torr from the water pressure, because I want the pressure of the CO2 alone. So this is going to be equal to 765 minus the pressure from the water vapor. And I'm going to go ahead and make this atmosphere since I'll need to here in a second. So I'm going to subtract the 28 and then divide by 760. .970 atmospheres. Okay, I have my pressure. My volume is straightforward, 2.5 liters. N is what we're going to calculate. R is a constant. And T is here somewhere, 29 degrees C. So 29 plus 273 makes it be 302 Kelvin. All right, let's calculate N now. N is equal to PV divided by RT. Okay, so I get 0.0979 moles of CO2 were formed. And I want to know how many grams of carbon were in that sample. Okay, and the CH4 is the only source of carbon, and so all the carbon that we have in the CO2 came from the CH4, and so I'm just going to do this. So for 1 mole of CO2, I get 1 mole of carbon, and then I'll use my periodic table. 12.01 grams of carbon is equal to 1 mole of carbon. Okay, so I get 1.18 grams of carbon are contained in that sample.